So we were just talking about ordered pairs, and remember we are graphing in this chapter. So we are going to learn how to graph things in 2 dimensions, and so that's x and y. Now when we look at ordered pairs always go x comma y. And when I say plot, that means we put a dot where they belong. We are not going to be connecting them together. When we connect them together, that's graphing. So there's a very distinct difference between plot and graph. So we're going to plot these points here. Students sometimes mix them up. Ordered pairs always go x, y. So let's plot the point 3, -2. So 3, -2 would be over 3 and down 2. So 3, -2 would be there. Okay, over 3, down 2. What about 4, 3? Well, 4, 3, remember, x goes first. So that's over 4 and up 1, 2, 3. And it's right about there. And the last one is -2. So that's back 2 units. And then up 4. So -2, +4 would be right about there. So that is how you plot ordered pairs. Plot does not mean connect them together. I did not connect these together. All I did was put a dot where the points are. When we graph, that's when we connect them together. When we have ordered pairs, we can also find the midpoint. So we're going to be learning how to find the midpoint. In college algebra, you'll learn about the midpoint, and you'll also learn about the distance formula. So in college algebra, you'll learn about the distance formula as well. You're welcome. Okay, so our midpoint formula is easy. Midpoint formula is just an average. And the midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. That is going to be our midpoint formula. It's 2 ordered pairs. So the midpoint formula is actually very easy to do. So I'm going to give you some ordered pairs, and we're going to find the midpoint. We'll do 2 of these, and then we'll look at how to do it when you don't have one of the endpoints. So the first one we're going to do, we're just going to find the midpoint. And we'll do 2 examples of these. So how about 3, -7, comma, 4, -9. So we want to find our midpoint. Now, when we go to find the midpoint, we need to make sure we label the ordered pairs. Now, the way we label the ordered pairs for the midpoint is going to be the same way that we label our ordered pairs when we talk about our slope in the next section as well. Well, a couple sections down. So in 2-3, we'll talk about the slope, and it's going to be labeled the same way. So we take our ordered pairs and we label them x1, y1, x2, y2. So those are our ordered pairs. And now we're going to apply our midpoint formula. So here's our formula up here. So we're going to apply it. So in our case, our midpoint would be adding the x's together over 2, adding the y's together, and dividing by 2. So we've got x1 plus x2. So that's 3 plus 4 over 2. And then we've got the y. So we have a -7, -9, right? Because they add together over 2. And what does that reduce down into? All right, we need to break it down if we can. 3 and 4 makes it a 7 over 2. And -7, -9, well, that makes it a -16 over 2. And break it down if you can, because -16 over 2, well, that reduces down to a negative 8 decimal. So there is your answer as an ordered pair. And the midpoint is an ordered pair. It's basically like a location on a map. Longitude and latitude are like your x and your y. So this would be like a point on a map. So we have to break it down if we can. Let's do one more, and then we'll do it the other way, backwards. So we're still going to find the midpoint. And let's say I give you minus 8, positive 4, and 2, 12. First thing we do is we label our ordered pairs, x1, y1, x2, and y2. What do we do for our midpoint? Well, our midpoint formula, a lot of times I like to write it down, just so we have it again. That is x1 plus x2 over 2, comma, y1 plus y2 over 2. And we'll fill this in. So it's going to be minus 8 plus 2 over 2. And 4 plus 12 over 2. Move it up so we can see what we have here. So I do like to write up the formula. If I don't see it, that way I have it. So I like to write it for it, fill it in. And now we'll just do our arithmetic and then reduce. So minus 8 plus 2, that's a minus 6 over 2. And 4 and 12 makes it 16 over 2. And what does that reduce down into? Well, minus 6 over 2. That reduces down to be a minus 3. And 16 divided by 2. Well, that is a positive 8, isn't it? Sorry about that. 16 divided by 2 is an 8 there. So is everyone okay with how I found the midpoint? You just add them together. And you divide by 2. Now, if we want to... Are you ready for that example? Would you rather take it on Thursday? Would you rather take the exam on Thursday and just say for the... Okay. So what we were talking about just a moment ago was we were finding the midpoint. Now I'm going to have you find one of the endpoints. So what I'm going to give you now is I'm going to give you the point. This is going to be just like your homework here. I'm going to give you a point. So I'm going to give you a point. If they give you P, if they give you the point P, and let's say that point is 4 comma minus 2.7, and then we have a midpoint, and that midpoint is labeled M, and let's say it's 1.9 comma minus 2.3, and I want you to find the other endpoint Q. So this one is a little bit different. So I give you a point, and I give you, in this case, the midpoint. I want you to find the other endpoint Q. Well, Q, we're going to label this. This is our point here. We're going to label this X and Y. Now, this is our midpoint right here. But P and Q are the points that we're going to be using. So P is going to be X1, Y1. Q is going to be X2, Y2. So it is a little bit different. Let's write up our formula so then we can plug in our pieces. And the midpoint is X1 plus X2 over 2. And Y1 plus Y2 over 2. And we're going to fill our pieces in. Now, X1 and Y1, we can plug those in. Those are numbers, but x2 and y2 are unknowns. They're the variable x and y. Now, what do we know about the midpoint? Well, the midpoint is right here. And the midpoint is 1.9, comma, minus 2.3. That is your midpoint. M represents the midpoint. Now, what about on the right-hand side? Well, on the right-hand side, we have 4 for x1 plus x2 over 2. And then we have a minus 2.7 plus y, because that's y2 over 2. Now, what we're going to look at is we're going to separate this into two separate pieces, an x part and a y part. We'll find the value of x, and then we'll find the value of y. So let's look at the x part. So on the x part, that's going to be everything that's in front of the comma. So on the x part, what do we have? We have 1.9. That's this piece. It needs to equal 4 plus x over 2, right? Because that's the x part. Everything in front of the comma is the x part. Now, how would we finish this and find our value of x? Well, we would simply write that as over 1, and we could cross multiply. So we'll go ahead and cross multiply here. So we've got 1.9 times 2, and that's a 3.8. When we cross multiply, it equals 4 plus x there. We just simply cross multiplied, right? We're going to go ahead and move that 4 over. Watch your signs here. When I move that 4 over, I have 3.8 minus 4. So 3.8 minus 4, that is a minus 0.2. Okay. Is everyone all right with that? So that is the x part. Now, what about the y part? Well, the y part is going to be everything behind the comma. So the y part is going to be this here. So for the y part, what do we have? For the y part, we have a minus 2.3. That is going to equal minus 2.7 plus x over 2. And we're going to solve this the same way we did the last one. So put this over 1. And then we'll cross multiply. Use a calculator if you need to. If you have trouble multiplying in your mind, you can use a calculator. So 2 times 2.3. That is a 4.6. It's a negative. So we have a minus 4.6. That equals a minus 2.7 plus x. We'll add the 2.7 over. That then leaves us with x equaling now what? We've got a minus 4.7. Or, sorry, minus 4.6 here. Plus that 2.7. That gives us then a minus what? 1.9. What would the answer then be? All right, the answer as an ordered pair would be what? Would be minus 0.2, comma, minus 1.9. That is going to be your final answer as an ordered pair, and that's what we wanted. We did want the other endpoint q. So let me adjust this a little bit here. So is everyone all right with how I did that? There's only one of them in your homework like that, and that's question number 8. 5, 6, and 7 are just finding the midpoint. So now that we've talked about ordered pairs, now we're going to learn how to graph lines. And we're going to begin by looking at intercepts, what they are, and then how we find them. Now, intercepts are going to be where the line touches the axis. Now, in many cases, we have both an x and we have a y-intercept. But sometimes we only have one or the other. So I'm going to give you some pictures to look at first so we can visually see what intercepts are, and then we'll find them. So here's a graph of a line. So I'm going to graph a line here, and we're going to find the intercepts. So let's go ahead and graph this line. We're going to find the intercepts as ordered pairs. So here's our line. Now, this line has an x-intercept and it has a y-intercept. So we look at whichever axis it crosses. So this is the x-axis and this is the y-axis. So when we look here, right here is where it crosses on the y-axis, isn't it? So right here, that is called my y-intercept. And the y-intercept is an ordered pair. The x part is at 0, because here's your x-axis, it's at 0. And how many units did I go up? 2. So my y-intercept from that picture is the point 0, 2. And that is your y-intercept. Now, what about this one here? We have where it crosses the x-axis, and that is your x-intercept. And the x-intercept, as an ordered pair, would be moving over 5. And we didn't move up or down any. So it's at 5, 0. So in this case, it has both an x-intercept and a y-intercept. And that is visually what it looks like. When I teach graphing in Chapter 2, I like to do a lot of visual parts. So you see what it is and see what intercepts are before we actually calculate them. What about a vertical line? I'm going to give you a vertical line, and we're going to talk about its intercepts. And this, by the way, would be x equals 3. So that would be the equation of that. X lines are vertical. So this is the line x equals 3. Now, what do we know about the intercepts? Here's the x-axis. Here's the y-axis. Does this line right here, does it ever cross the y-axis over here? No, it doesn't, does it? Right, because it's a vertical line, so it has no y-intercept. But what about the x-intercept? Okay, well, the x-intercept would be where? The x-intercept would be right there, and as an ordered pair, it would be 0, what? 0, 3. So a vertical line is an x line, because that's the axis that it crosses. It has no y-intercept, but it has an x-intercept. What about a horizontal line? Well, a horizontal line, what would that look like? Okay. Horizontal line would cross the y-axis. So here's an example of a horizontal line. And the equation for this horizontal line would be y equals, in this case, a -2. Now we're going to talk more about the equations later on today. And you'll learn about an x line, a y line, and you'll learn about the diagonal line. But right now we're just trying to understand the intercepts. What about this one? Does this have an x-intercept? Do we think this has an x-intercept? Here's your x-axis here. Does this line ever cross the x-axis? No. So do we have an x-intercept? No, there's none. Okay. What about the y-intercept? Well, the y-intercept would be here. Okay, it crosses the y-axis right there. And what would it be as an ordered pair? Well, as an ordered pair, remember, x always goes first, so you're not going left or right any. So that's at 0. And how many units down is this horizontal line? -2. So my y-intercept, which is here, that's your y-intercept right here, that would be 0, -2. And I like to make sure you see visually what it looks like. Otherwise, when we just start calculating them, you're just running through some math. So I really like to make sure we see how it all visually goes together. Now, if I give you an equation, how do we find the intercepts and graph it? So here's an equation that I'm going to give you. We are going to find the intercepts, and we're going to graph it. So we'll start off with this one. Okay, now, we want to find the intercepts. These are ordered pairs. We have an x-intercept and a y-intercept. Now, if you have x and y both, that means you have both intercepts. This is going to be a diagonal line. Y lines are horizontal. X lines are vertical. When you have both the x and the y, it's going to be diagonal. And we will have an x-intercept and we will have a y-intercept. Now for the x-intercept, we're going to be finding the x value. So that's going to be blank, comma, 0. For the y-intercept, that one's going to be 0, comma, blank. And we need to fill in the blanks. How do we do that? Remember, this is your x and this is your y. So on this one, we're going to plug in y equals 0 into the original. And we're going to see what we get. So we get 3x plus y equals -6, but we know that that y is 0. So we replace that with 0. And 3x plus 0 is still just simply 3x. So 3x equals now our -6. We'll divide by our 3. And now we've got it as x equaling a -2. So my x-intercept is the point, and it's an ordered pair, is the point -2, comma, 0. You always want to use the zeros. What about the y-intercept? Well, the y-intercept, in that case, we're going to plug in x equals 0. So for the other one, we plug in x equals 0. And we've got 3x plus y equals -6, but we know that that x is going to be replaced with 0. And 3 times 0 is 0. And that leaves you then with y equals now a -6. So here are your intercepts. You've got an x-intercept and you have a y-intercept. Now, a lot of times students will try to do this. This is not correct. Do not write it like that. They are separate ordered pairs. So do not, and I've seen over the years, Many students try and do this. They found the two values and they plug them in like that. That is not correct. You have to have 2 points to graph a line. 2 different points. These are both 2 different points. So we're going to now graph this line by plotting the points and then connecting them together. So we've got our 2 ordered pairs. So now we're going to plot our points, connect them together to make our graph. So we've got -2, 0. So that is back 2 and at 0. So right there it is, -2, 0. What's our other one? Our other one is -6 for the y part, 0 for the x part. So 0, -6, that means we don't go left or right any. We're going to go down 6. So 1, 2, 3, 4, 5, 6. And that's going to be down 6. As an ordered pair, that would be 0, -6 right there. And we are going to graph it. So that means we connect them together with a ruler or a straight edge. And so when we connect them together, it looks like that. Okay, so there's the graph. That is your x-intercept. This one is your y-intercept. Pretty easy. What happens if they both come out to be the same? What happens if they're both 0, 0? So let's look at this one. We're now going to try to find the intercepts again. And graph. So we're going to try to find the intercepts and graph. And here's my equation. Y equals 7x. Well, what do I need to do? I need to find my intercepts. So to find my intercepts, I'm going to label them. We should have an x-intercept. And that x-intercept is 0, blank. And then we'll have a y-intercept, which is which is 0, blank. Now, the last one, these were different. So for the last one, when we plugged in, remember here's your x, here's your y. When we plugged in y equals 0, we got a number that wasn't 0. If we plug in y equals 0 here, what's going to happen? If I plug in y equals 0, you get 0 equals 7x. We'll divide by our 7, but what does that leave you with x equaling now? 0. Same thing on the other one. If you plug in x equals 0 over here, then you get y equals 7 times 0, which is then y equals now 0. So, what do we know about these? These points are the same, aren't they? And here's something that we have to remember. Whenever we graph a line, we need 2 different points. If we've got 2 different points, we can connect them together with a ruler or a straight edge. Unfortunately, these points are the same, aren't they? So we need to come up with another point. We have to have 2 different points. So since these are the same, we need another point. And we can use any point that we want. So since the intercepts are 0, 0, we need another point. So I'm going to use x equals 1. You can use any point that you want, any value for x. And so we're going to plug in 1, and we're going to fill in the missing part. And we can use any value for x that we want. We want to keep it pretty easy. So if we've got the double 0, you need another point. And so I'm just going to plug in x equals 1 and work that out. So y equals 7x. Well, if your x is 1, that gives you y equals 7 times 1, right? So y equals now what? 7. We now have two different ordered pairs. We've got our first ordered pair, which is at the origin, at 0, 0. And we've got our second ordered pair that is at 1, 7. So it's over 1 and up 1, 2, 3, 4, 5, 6, 7. Now we can connect them together with a ruler or a straight edge. And that's going to be our graph. Okay, so we've got our 2 points here. We'll connect them together with a ruler or a straight edge. And there is your line. And by the way, what are the intercepts? We found them. And for the intercepts, we have an x-intercept. And that was at 0, 0. And we have a y-intercept, which is also at 0, 0. Now, what about if you only have one variable? So let's try this one. This one is actually easier. Let's find the intercepts and graph. Let's use, how about x equals negative 4? What's different about this one versus the last ones that we've done? Okay, on the others that we've done, we had an x and a y both, right? But this one only has an x. So it only has an x equals negative 4. So we need to first figure out what this would look like. We can graph this one by itself. Because if you got x equaling a negative 4, then that means that is just a vertical line, right? Because this is your x-axis here. So this is going to be a vertical line right through that negative 4. Okay, that's x equals negative 4, and that's what the graph would look like. Now, what about our intercepts? Well, it does cross the x-axis right here, and that would be the point. Counting over, 1, 2, 3, 4. That would be the point minus 4, 0. And for the y-intercept, we have none. Okay, so no y-intercept. Now, if this would have been a y line, what would it look like? If x lines are vertical, okay, what do you think a y line is going to look like? It's going to be horizontal. Okay? And it'll have a y-intercept, but no x-intercept. So that should have now finished up to point 1. I think we've covered everything. We'll just kind of go over these from our homework. We're going to talk about them quickly. I'll just put it up on the screen. We'll go through them all. I'm not going to work them out, but we're just going to talk about them. So like the first one, what do they want you to do? Okay, if you look at your homework here, they want you to figure out which one of these is negative 5, negative 4. Figure out which one it is, no problem. What about the second one? Well, they want you to complete the ordered pair. So that means for each one of these, we're just going to plug in the values. So for each one of these, we would plug in this case, 2. So that would be 2 plus y equals 6. Move the 2 over. So that would give you y equals 4. And so on. Okay, you plug those values in for x. Find the missing value. What about question 3? Question 3 is almost the same. We plug in the x values. they give you, and we find the y values. We get those points, we plot them, and then we graph our equation. So we've done those. Question 4 is very similar to what we just did. I think we did a -4, but this one's a +4, so you can graph that one. So find the x-intercept, the y-intercept, and graph it. And we just did one like it a moment ago. 5, 6, and 7, what are we doing here? Finding the midpoint. We did those at the very beginning. Question 8, well, we did one of those. Remember, that was where we had to find the missing endpoint. Question 9, we did one of these, right? We just did one of them earlier, where you're going to plug in your x and your y equals 0, find your ordered pairs and graph it. And same thing with 10. So you'll just work with 10 here. Now, I will make it a little bit easier for you on question 10. You'll want to clear the fractions, and you can do that. I'm not going to finish out question 10, but I'm going to help you clear the fractions. And you can do this. This is not a problem at all. If you struggle with fractions, clear them out. How would you clear the fractions here? What would you multiply this by? Can anyone tell me? We took a test over this last week. How would you clear these fractions? Multiply it all by what? Multiply it all by 5, right? Yep, someone said it 5. So if we multiply all of this by 5, it's going to make it much easier to work with. And you can do that. So you can clear the fractions just like you've done before. It's not going to change any of the answers. So the 5's cancel, and that leaves you with 11x. The 5's cancel, that leaves you with 3y. And don't forget, 5 times 6 is a 30. And now I want you to find the intercepts. It's just easier if you clear the fractions. But I picked that one because I want to show you that you can clear the fractions. You could do it without, but I think students struggle more. So why don't we just get rid of the fractions to begin with by multiplying it by 5. And you can do that. That is a legitimate way of solving these. Then we work with the whole numbers, which is easy. You'll find your intercepts, and then you'll have to graph it. We have enough time left, I think, to at least start 2.2. And there's not much in 2.2. 2.2 is another quick, easy section to go through. We may actually finish it. We'll see how much time we have and how far we can get through. But 2.2 is all about the slope. So 2.2, we're going to be learning how to find the slope. We're going to first look graphically at what the slope is. And the slope, by the way, is just a number. Slope is also called the pitch or the grade. And it's a ratio, it's a number, it's a fraction. It's rise over run. And it's many times referred to as the variable m, and it is rise over the run. And the rise, well, that is the y part, and the run, well, that is the x part. It's also called the pitch or the grade. If you build a house, the roof has a pitch. Right? Pitch is just like the slope, just that different professions call it different names. We call it the slope in mathematics, but it's just a ratio of the rise over the run. Now, I'm going to give you 4 graphs here, and we're going to talk about each of these, and we're going to talk about what the slopes are. We need to make sure that we understand the basics of the slope. So each of these we're going to talk about the slope. Okay. Now, there are 4 different outcomes for the slope. It can be positive, negative, 0, or undefined. When I look at the first one here, what is it doing? Now we read from left to right and we follow it down. So what is it doing? Is it going up or is it going down from left to right? If you look at this from left to right, it's going what? Down. So in this case, this one would have a negative slope because it's going down from left to right. What about this one down here? What is this one doing from left to right? Well, this one is going up, right? So up from left to right. So it's going to have a positive slope. Now let's talk about these two. One of them is undefined and one of them is 0. Does anyone remember from the previous classes, is this going to be undefined slope or a 0 slope? Which one? Undefined. Okay. Why is it undefined? Because it's a vertical line. So vertical lines the slope is undefined. What about horizontal lines? This one would have a slope of what? Does anyone remember? This one would be a slope of 0, wouldn't it? Horizontal lines have a slope of 0. Vertical lines are undefined. The way I remember these is I think of it as like a roller coaster. If you're on a roller coaster, as I look at this one, what's happening here? Okay, this roller coaster is going down. So that has a negative slope. Can I go straight up on a roller coaster? No, it can't do that, right? It'll fall off the track. So that's why it's undefined. Can't be done. On a roller coaster, when you come up, this is where you would go back to the track, back to the gates, right? Horizontal line, you can do that. That has a slope of 0. As the roller coaster goes up, it has a positive slope. So just think of it as a roller coaster. That way, remember, I can't do this on the roller coaster, right? It would come off the tracks. So this one's negative. This one's undefined because it's a vertical line. This one's horizontal, 0. You're not doing anything. This one's going up from left to right. Now we're going to talk about lines and how to graph a line when you're given a point and a slope. Okay, so I want you to graph this line when you're given a point and a slope. So there are basically 3 ways that we can graph a line. We can graph a line when we have 2 points, we can connect them together. We can graph a line when we have a point and a slope, because that's basically 2 points. And we can also graph a line when we have an equation, which we'll talk about later today. So what we have right now is we have a point and we have a slope. I want to graph this line. So what do? Well, I first begin by plotting that point. So we find our point. And our point in this case was -4, +2. So it's right here at -4, +2. Now, what about my slope, m? Well, it is 2/5. This is rise over the run. So that means we're going to go up 2 and we're going to go over what? 5 units. Now, where do we start at? We start right here. Okay, so this is the starting point. So we start at our point. We start at this point, -4, +2, and we're going to go up 2 more units. And then we're going to go over 5. So 1, 2, 3, 4, 5 units over. And that makes my second point right there. And you can even label it if you want. Okay, we went up 2, so that makes it a 4 there. And we went forward 5, so -4 + 5 makes it a 1. There's my second point. You don't have to label it. I sometimes do just to make sure we understand the point, but you don't have to. You just have to connect them together. So that's how you graph a line when you're given a point and a slope. We'll do one more, and then I'm going to give you a picture of a graph, and you're going to find the slope from the picture. So we're going to graph the line. You're given a point and a slope. So how about we use 1, 2, and I'm going to give you a slope of -3. So don't try to make these harder than they need to be. All I want to do is graph this line. So where do I start at? 1, 2, x and y. So that means we go over 1 and up 2. There's my first point. That's 1, 2. Now, what about my slope, m? Well, my slope is a -3, and that's going to be a -3 over 1. So we're going to have to go down 3 units and over 1. Where do I start at? I start right here. This is where I start. So this is where I start. We're going to go down 1, 2, 3 units. And we're going to go over 1. That makes my second point, and you can label it if you want. You don't have to, but I'm going to go ahead and label this as an ordered pair. This would be at +2, comma, -1. Again, you don't have to label them. I do, though. Connect them together. And that makes our line. Now, how do I know it makes sense? Well, what do we know about a negative slope? A negative slope should go down from left to right. Is this line going down from left to right? Yeah, so we know we did it correctly. What about this one up here? This one was a +2/5, right? And it went up from left to right, and it matched. Now I'm going to give you a picture. I'm going to give you a graph, and you're going to have to find the slope. So here's a picture. I want you to use this picture to find the slope. What are we going to do? Well, first off, what do we know about the slope? Do you think it's going to be positive or negative? Which one and why? Positive number or negative number for my slope? Anyone want to take a guess? Positive or negative? Okay, it's going to be negative, isn't it? Why is it going to be negative? Because you're going down. So your slope should be negative. Now, I want to go from one point to the other. So from one x to the other. So to get from this point to this point, What'd you say? Yeah, are you finished with it? Do you want to take some more time to finish it then? Okay. Yeah, I grade it whenever you finish it. Okay. So yeah, you need some extra time. Go ahead and take all the time you need to finish it. And just bring it back to me whenever you're finished. Okay, so we know this should have a negative slope, so we're going to have to go down 4. And then we're going to go over 2. Now, slope is defined as rise over the run. And what do we know about the rise here? Well, we know it should be a negative number. My rise, how many units did I go down? I went down 4, and then it went over what? 2. So negative 4 over 2 makes it a negative 2. So what is the slope of this line? Negative 2. That's it. That's all I want. And there's a couple of these on there where you just want to find the slope. Next, we're going to learn how to find the slope from an equation. And we have what is called slope-intercept form. And you probably have seen this before, but the slope-intercept form is y equals mx plus b. And the m, well, that is the slope. And the b is the y-intercept. As a point that's 0, b. So we'll do a couple of these where you find the slope and you graph. Then we'll learn how to find the slope when you're given 2 points. And then we'll talk about parallel and perpendicular lines. So a little bit more material to cover. But let's, on these, find the slope and graph. And I'll give you one that's already solved for y. So how about y equals 1/2 x minus 3? So I want you to find the slope and graph this line. First off, has it been solved for y? Yes. If it has not been solved for y, you'll need to do that. So the number in front of the x is the slope. So in this case, my slope would be 1/2. And what about the 3? Be careful with the signs. That 3 is negative. So that's going to be the y-intercept. (-3). Now we can graph it because what do we have? We have a point and we have a slope. So plot your point. That's at 0, (-3). So that's down 3. And what are we going to do? My slope is 1/2. So what does that mean? That means we go up 1 and over 2. So you can draw arrows if you want. I'm going to go up 1 and then over 1, 2. 1 over 2. Make your point. Connect them together. And there's your graph, right? Up 1 over 2. So you just started at that point, 0, (-3). And then we went up 1 unit, and then we went over 2 units. Let's do one more. Now this one we're going to have to solve it for y. And again, same directions. I want you to find the slope and graph. Well, if I want you to find the slope and graph, what do we need to do? We need to get this in slope-intercept form. So the first thing we're going to do is we're going to solve it for y. Very important. You solve it for y. So move that 4x over. That gives you a (-3y) equals a (-4x) plus 9. We'll divide by our (-3). And be careful with your signs. So that leaves me now with y equaling 4/3 x. 9 over 3 is a 3, so that's going to be 4/3 x minus 3. What would my slope m be? M is the number in front, so that's 4/3, right, number right in front of the x. What about the y-intercept? The y-intercept would be 0, -3 again. When we go to graph it, we're going to start at 0, -3. That's right there. And then what are we going to do? 4/3, so that's up 4 and over 3. So up 1, 2, 3, 4. 4 units up and 1, 2, 3 units over. Make my second dot and connect them together. Pretty simple. So if it's not been solved for y, you've got to make sure you solve it for y. Last part before we talk about parallel and perpendicular lines is we'll talk about how to find the slope when you're given 2 points. So if you're given 2 points, you can find the slope, and it's easy. And this is going to be our slope formula. So the slope formula m, okay, m equals y1 minus y2 over x1 minus x2. So this is our slope formula. Now y is on the top because y is the up and down part, and that's your rise. So rise was on the top. Run is the x part, so that's your left and your right. So it's down below. So here's our slope formula. We're now going to find the slope. And you're going to be given 2 ordered pairs. So how about 5, 7, and 4, -3. Just like we did earlier today, we label our ordered pairs x1, y1, x2, y2. And then we just simply plug them in our formula. So m equals y1 minus y2 over x1 minus x2. So we plug our values in. So that is 7. Now, watch the signs here. 7, that's your y1, minus a -3. So you do have a double negative here. So that's 7 minus a -3. And that's going to be over 5 minus 4. Right? Those get subtracted from each other. We know the double negative here is going to make that positive. 5 plus 3 is 10. 5 minus 4 is a 1. So my slope would then be a 10. Let's do one more. How about I want you to find the slope again. And let's say you're given 4, 8, and 4, -15. x1, y1, x2, and y2. Write up your formula if you need to. M equals y1 minus y2 over x1 minus x2. And then we just fill them in. Again, watch for double negatives. So that is 8 minus a -15 over 4 minus 4. Double negative makes that positive. 8 and 15 is a 23. 4 minus 4 is 0. Is this 0 or is this undefined? Which one is it? 0 or undefined? Can you take a number and divide it by 0? No, right? If you have 0, you can take 0 divided by 4, right? 0 divided by 5, those are all 0. But what about 23 divided by 0? 0's down below. You can't do that, so this is called undefined, right? It's not a real number, so you cannot divide a number by 0. You can take 0 and divide it by a number, but 0 can't be in the denominator. So that one would have a slope that is undefined. The very last part is parallel and perpendicular lines, and it won't take long to go through. Parallel lines, they have the same slope. So that would be something like m equals 3 and m equals 3. An example would be y equals 3x plus 4 and y equals 3x minus 12. Okay, why would these lines be parallel? Both of these lines have a slope of what? 3. If the slopes are the same, then they are parallel. So these are clearly parallel lines. What about perpendicular lines? Well, perpendicular lines have the opposite or negative reciprocal slope. I say opposite because I think students are less likely to make a mistake. So when I talk about perpendicular lines, you can either say opposite or negative reciprocal slope. I use opposite because I think it's easier to understand. So they have the opposite reciprocal slope. And what does it mean if we have opposite reciprocal slope? Well, that would be something like 5 for one, and the other one is minus a fifth. Another example might be negative 2/3. The opposite reciprocal would be switching that sign. That would be a positive 3/2. So I flipped it over. This is over 1 here, right? Flipped it over, makes it 1/5. Change the sign. This one's a minus 2/3. Flipped it over, becomes a 3/2. This is negative. Change it, makes it positive. So what would lines look like? Okay, here's some examples of these. These are perpendicular lines. How about y equals 5x plus 2? And the perpendicular to that line would be, how about y equals minus 1/5 x? Those are perpendicular. Let's look at one more with these examples. Another set of examples would be y equals minus 2/3 x plus 4. And a perpendicular line to that would be y equals 3/2 x minus 2. Look at the slopes. We don't care about the number on the end. All we care about is the slope. So now we've talked about parallel and perpendicular lines. Let's do a couple of these. We'll do one. I'll pass out the sign-in sheet. And we'll do the last one. So let's do one question. And then we'll pass out the sign-in sheet, do one more, and that'll be it for today. So 2 more questions. And we're going to look here at parallel and perpendicular lines. So what we want to look at is we want to see if these are parallel, perpendicular, or neither. So are these lines going to be parallel, perpendicular, or neither? Now, you have to solve for y. So you must solve for y. So that's where you always begin. You always have to solve it for y. Now, sometimes they might already be solved for y. But if they are not, then you have to do that. So this one's going to actually be already solved for y. Here's the other one. This one is not. So are these lines going to be parallel, perpendicular, or neither? We've got to solve it for y to see. What would the slope of this line on the left be? This one has already been solved for y, hasn't it? So it's easy. Its slope is just simply m equals 3. Easy enough. Now, what about the other one? Well, the other one, we're going to have to move that 3x over. And that leaves you then with minus y equals 3x plus 4. Divide by our negative 1. And now we've got y equals a minus 3x minus 4. And this one has a slope of negative 3. So sorry about that. We'll finish this one up real quick here. So are these lines going to be parallel, perpendicular, or both? Well, for them to be parallel, the slopes need to be exactly the same. These are not, are they? Now, for them to be perpendicular, they would have to be reciprocals, flipped over. These are not either, so these would be neither. Neither parallel nor perpendicular. So we'll do one more, and this will be our last question. And let me go ahead and pass out the sign-in sheet. Last question for today. And again, same directions. Parallel, perpendicular, or neither. These lines are going to be parallel, perpendicular, or neither. I'll make an example we can work through. So let's look at this one real quick here. Now, are these lines going to be parallel, perpendicular, or neither? Well, what we always need to do first is solve it for y. So we're going to take these, and we're going to solve these for y. So it doesn't take long to do. Move that 3x over. So now we've got 2y equals a minus 3x plus 4. Divide by our 2 and reduce. So that leaves you now with, when we reduce, y equals a minus 3/2 x. And 4 over 2 is a 2. And so what would my slope now be? The slope is the number in front of the x. And so that's a 3/2. Now, what about the other one? Same procedure. Move the 2x over in this case. So 3y equals 2x plus 7. Divide by our 3. And now we've got y equals 2/3 x plus 7/3. And so my slope m would be what? 2/3. Now, parallel, perpendicular, or neither? First off, are they opposite in signs? Yes. Are they flipped over? Meaning reciprocal, meaning they're flipped over. One's flipped over the other one. Yes. So these would then be perpendicular. Because they are opposite or negative reciprocals. And now let's quickly talk about our homework. And your homework, you should be able to do 2.1, do them all, and 2.2. You should be able to do them all. Now, if you haven't